Okay, hello everybody. Hopefully you can hear me. Let's see. We are at the TWiML AI Fast.ai Deep Learning Study Group here. So for those that have not been with us before, we've been doing this for kind of like the past 6 weeks based on the recorded lectures. But so for the lectures that just started on Monday, the live lectures, we're resetting and restarting our study group for that. And so the live lectures, you know, somebody's calling, I think Jeremy's calling it V3. And so basically, I guess the presentation, in case you don't have it, I guess I'm going to put it in the chat so you have that. Or let's see, chat somewhere.
I'll do it.
Okay.
Sebastian, I'll do it.
Oh, Mikhail, you're on? Okay.
Yeah.
He's back.
Okay, great. Yeah, so we're just at around here, Mikhail. So
yeah, sure.
Let me share. I guess I'm going to give you the screen or something. Let's see.
I mean, I can share the presentation. You can continue, I guess.
Oh, okay.
If you want me, I can take. Yeah, we created a short presentation to start the course. It's going to talk about the study group. We're going to show you how to run the notebooks, a little bit about lesson 1. And we have a couple of mini presentations, like short presentations prepared for today. Something I would like to also suggest that anyone can present in the meetup. And then what's for next week and a couple of resources. So that's the short agenda. We can go to next slide quickly. Right. So we will be rotating as hosts for this study group. So we're going to have 8 weeks, because there is a 1 week of Fast.ai, they're going to skip 1 week. So we're going to have like maybe 2 weeks for the last lesson 6 or something like that. So yeah, we're starting today, and for the next 8 weeks, we're going to meet weekly at the same time. So we can go to the next slide. Yeah. So about the study group. So the goal of the study group is to provide support and encouragement for the course participant to help them overcome any rough patches, stick with it longer, and learn more. We're going to use the Fast.ai channel at the TWiML Slack, and also we're going to have the weekly Zoom sessions like this one. Correct, it's the next one. So the format of the group. So as I mentioned, we're going to rotate as hosts. There are a couple of us that made this presentation. So Sam Charrington is traveling today. Maybe you mentioned that he couldn't join today, but he says hi to everyone, and he will be with us next week. We want to encourage participants to do like a mini presentations, like say 5 minutes or so. So Kai will be organizing this.
Yeah. So maybe last time we did this, when we did the course last time, we also did this with the 5-minute presentations. And I think this time we want to aim at doing presentations more that are revolving more around the library itself. So we had pretty stuff that went really deep into detail, and I think at least for the beginning this time we want to more do presentations on the library itself. So for example, let's say next time someone wants to show, or maybe I will show something about the image data bunch class from the library, or any other class, or some of the mechanics inside of the library. And yeah, that's what we want to aim at least for the first lessons. And if you want to do a presentation, I can highly recommend it. You just reach out to me on Slack, and then we can plan that for the sessions.
Okay. So this is just to give an agenda. As I said, we're going to meet weekly. And then between lessons 6 and 7, there is 2 weeks in between. So I guess we're going just to continue meeting weekly for that. So our study group is 9 o'clock Pacific. And of course, Fast.ai is 6:30 Pacific. Yeah, so there are a couple of options how to run notebooks. I've put like together a summary of what's available on the forums. So there are a couple of like ready to run easy options, like Paperspace Gradient, Salamander. They are very easy to set up and also inexpensive options as well. Colab is free. It's a little bit harder, not too much. You just need to run one line of code before each lesson, and then you can run the lessons for free. Basically, it's not the fastest one. I know it's not such a smooth ride, but I think it's quite a good option. And then a little bit harder is SageMaker, and Cressel is also working. I've tried and it works. However, officially it's in testing. And then a couple of options that require some installations, that Google Cloud Platform and the Amazon EC2 services. So the Google Cloud is quite a good option. It's not that difficult to set up. And for the new users, they give $300 credit. So I think that's quite a good option if you're comfortable doing some, not too much installation. And then although the local machine with GPU setup is not recommended by Jeremy, but if you feel that you want to do it, Kai is willing to help you with that. Do you want to say a little bit about this, Kai?
Oh yeah, well, I am running my own workstation, and I'm using Docker to kind of manage all my different environments I use. And yeah, if you want to do that, I only would consider that if you know something about Docker and Linux, then you can consider that. If not, it's going to distract you, and I would not recommend it. I would go by using one of those Paperspace, yeah, and the other options. But if you really want to do that, you can just also reach out on Slack, and I can share my Docker files, and yeah.
Hey, Mikhail. For Cressel, is it running the version 1 library?
Yeah, you can do the version 1. They just relaunched Cressel AI. The old one was Cressel.com.
Oh.
And there's an official guide from in forums how to set it up. I've tried it this morning and it works. It's again that easy option. But officially it's still in testing. But so far it worked for me. Yeah.
Okay, I didn't know about the Cressel AI. I just went to Cressel.com.
I also wanted to point out that if you want to do the conda install, that's pretty easy as well. But I would only recommend it if you have a good GPU on your local workstation. But
yeah,
that's also pretty straightforward to follow.
Yeah, maybe the question to everyone: which options, what platform do you use?
Yeah, I have a comment. I went with Google Compute Platform. I had to install Ubuntu on my Windows laptop and then the Google command line interface and have a cloud platform instance created. That went pretty well. It took about 2 minutes to do lesson 1 notebook that fit for ResNet 34 with 4 epochs. That's about, I think, 30 seconds per epoch. I would be interested to hear the other platforms if it's much faster or much slower.
Yeah, I also took the Google Compute platform, but I installed it prior to the instruction from Jeremy, from some dude on the forums. I can't remember. I can look it up. And I don't know, I would be interested in Jeremy's instructions because because my instruction had me set up kind of 3 different instances, like a CPU only for downloading and saving money, and a light GPU version and a full GPU like V100 massive machine. And they're all these cheap instances that go away, right? So it was kind of comprehensive, but I didn't really check it. I just followed the instructions and they worked.
I actually managed to run it natively on Linux. We're having a small study group, so it actually worked fine having it running there, at least for the moment. There's a small graphics card, so we were able to run the first notebook. Probably when it gets more complicated, I don't know if it will work or it will take too long, but for the first notebook, it took like 2 minutes per epoch for the ResNet 34. So far, we're happy with that.
Which graphics cards are you running?
Quadro 2000M. It's not
Okay,
even
yeah.
one, but for the one it's working.
I'm running Paperspace and it's okay. It runs fast enough, but it's a bit frustrating because you can't get to the terminal. And if you want to modify the code or something like that to experiment, you can't. Right now, I don't think they give you a terminal. I don't know if anybody was able to find out a way to get to a terminal on Paperspace, but that's the downside of Paperspace.
I think you can. So if you can get that from Jupyter Notebook, basically. So if you click in a Jupyter Notebook on the right-hand side, you have new, and then you can either start new file or you can open new terminal. So you can
top right. Yep.
Yeah, you can get it that way.
Oh, on the file menu. Okay, because all right.
Yeah,
oh.
Yeah. So when you open your Jupyter and you have your files, then you can either like start new file or start terminal. Yeah, could do that. Mm-hmm.
Okay, cool.
Yeah, cool.
Should we go on next one?
Also on the forum, we see people using, some people use Salamander, Paperspace, Google Cloud, Colab. Yeah, someone's using Colab as well. That's right, terminal option. Someone's using GTX 1060 locally. Yeah, so lots of different options. That's right.
Oh, someone wrote that he used his MacBook with 16 gigabytes of RAM, and I just want to say that the RAM is not, it's not of a big use if you have a big RAM, because you need VRAM, you need RAM on your graphics card. So it does not matter if you have 16 or more gigabytes RAM on your laptop. It's not getting better. You need VRAM.
Yeah, it looks like it took 40 minutes per epoch, so I guess that's why it took so long.
Crazy. Yeah.
Because there is no GPU, and that's what speeds up.
Oh yeah, I see. Yeah, I see.
Yeah.
You wrote
Yeah.
40 minutes. Yeah.
Wow.
Yeah, so if you use GPU or any other platform like Paperspace, Colab, or anything else, you should see a huge improvement in the speed.
Yeah, it's crazy.
Yeah. There's a question from Jess. Why use Docker instead of just local install without Docker? I think that's a question. Okay. Yeah.
The thing is that you often have different dependencies. So for example, if you have different CUDA libraries and stuff like that for different environments you use, then this is going to be a problem. And also, I can't count how often I installed something and then broke the whole stack of software you need for deep learning. I mean, it's I really struggled a lot with that. So I decided to go for Docker, and you only have to install the driver graphics card on it only works on Linux. So you have to use Linux, and you only have to install the graphics cards drivers, and then you can containerize everything in a Docker container. And the good thing is that NVIDIA is giving you Docker containers, pre-configured Docker containers where everything is installed. So at the moment, they do not have PyTorch 1.0 containers, but I think that's going to come in the next few days with the next release. They are releasing in a monthly cycle for those containers. and it's really easy to use them. You can download them. You have Python installed. You have all the CUDA stuff installed, and I mean, the guys at NVIDIA, they know what they're doing, so it's optimized. And yeah, you can use those containers too. You just have to install the Fast.ai library, or I'm also using R and Keras, for example. And yeah, you can just install that on top of this container and use it pretty easy. So
how
once
big
you
is
have
the image
a set
of
of
those?
Docker images, then you can, it's really getting easy to use them.
I'm sorry to interrupt. I was kind of curious, how big is the images of those NVIDIA's containers?
Oh, they are pretty big. Wait a second. I can look on my machine how big those images are.
I've gotten in like at least 5 gigs.
Yeah, yeah.
Depending on what
So
you have.
the Fast.ai image, so the NVIDIA image and Fast.ai on top of it is almost 10 gigabytes. So it's pretty much. But Docker uses, so it's kind of stacking those layers. When you download the NVIDIA,
I think it's fair to point out that even the Corda environments, they back up huge sizes as well. So
sorry,
it's all
I didn't.
in that sense.
Could you hear him?
I have trouble hearing Sanya. It's very broken.
Yeah. Yeah, me too. So the good thing is that when you download the NVIDIA Docker container and then you build, let's say, 5 different environments on top of this, it's not copying the NVIDIA container. It's using this container and stacking everything up. So it's not that much overhead. And it's not, and the good thing is that it's literally no overhead when you start the container. It's really just this new file system that is inside the container, and you don't have overhead in terms of RAM or CPU. So it's not like virtualization. It's really just an isolated environment.
Do you have a blog post or something about the setup, maybe?
Sorry?
Do you maybe have a blog post or something where you?
Yeah, I do. I posted in the Slack in the chat.
Okay. Thanks.
I'm just reading the chat. Andrew saying that you can SSH into Paperspace, but do you mean the gradient or the virtual machine option? I was actually trying to upload some data from my local computer to Gradient this morning, and I was confused how to do it. But it seems to be there is quite easy way, because in a Jupyter notebook there's option upload, so I guess that can fix problems. But I will be also interested to learn if I can SSH into Gradient as well. But so if you know, please let me know. Thank you.
Yeah, that was just a result of a quick Google search in response to the earlier question. It's been a while since I've used Paperspace myself.
Okay, thank you. Yeah, because Paperspace gives 2 options. One is the Gradient, which is like the Jupyter notebooks, and the other one is like a virtual machine. They're a bit different. So I just wonder if you can SSH to Gradient. I will check that later. Yeah.
I seem to remember using
the documentation. It says that you can't. And the documentation was about a year old that I saw.
Right. Right.
Okay, so one more thing for Docker. I'm posting this link here. It's a GitHub repository. It's a Docker file for the last course. I did not update it to the new Fast.ai library, but there is a Docker file in the Slack channel, or I can also post in Slack the Docker file that I'm using at the moment. And there's also a blog post link that I wrote on why I do that. And I'm currently working on a tool to manage all those kind of Docker environments, a little command line tool, but I do not have that much time at the moment, so I don't know how long it takes to release that. Okay, so maybe we can go on now.
Yeah, so lesson 1, basically it was a good lesson, I think. Did you guys watch live or did you watch later on?
Was it live?
I watched live.
I admit that I watched it later.
I watched live, and you know, I think I have a lot of time on the weekend to do homework and small projects and things like that. So if we have the live lesson Tuesday or Wednesday or Thursday evening, my time, by the time on Saturday morning when we meet here to discuss, Saturday morning for me, I probably won't have had that much time to, other than maybe running through the notebook of the lesson. Because I would plan to be doing Saturday and Sunday. I have more time, and that would be the time when I would be able to do other things, other images, other interesting kind of projects. But it wouldn't be until after we meet that week.
Yeah, indeed, because they move lessons. So last one was on Monday. This next week is Tuesday, and some weeks it's like Thursday, I think even.
Right. So if it's Thursday night, and then Saturday morning we meet, I don't know how much time we're going to have to be doing other things in between.
Yeah.
You know.
Yeah.
You're right. So luckily we have the one lesson, one meetup that is in between that 2 weeks time, so we can catch up, I guess. And but we'll see how this goes. If it's not too much for everyone, and then we want to change the pace, we can of course do that. So far we're thinking to go like the same pace as the live course. Let's see how this would work for us.
Does anyone know if the link is going to change next time, or is it always the same live stream link?
It'll change. They'll post the link.
Yeah, maybe they won't even use YouTube this time. That's also a possibility.
Yeah, actually, they said that they will post the later links on their discussion forum, the Fast.ai private group.
Yeah.
Did anybody find it as interesting as I did? Of the first class when we started, I found it very difficult to pay attention. I had to cut it up into 2 pieces. But on Tuesday, I was able to watch it all the way through, and I understood everything. It's fun and a whole lot more interesting.
That's great. What was the most interesting?
Pretty distracted by the chat, to be honest. I was pretty distracted by our great chat, but.
Well, I think over the last 6 weeks, I've learned a lot. So now I understand.
Yeah, sure.
Fantastic.
So that's why it's a whole lot more interesting.
Right.
It was very difficult to get through.
Yeah.
I'm also going through the ML, and I'm finding that a lot more interesting. And he asks you actually to go do that if you want to know about random forests and so forth, if it comes up. And so it is worthwhile to do it at the same time. And I
found it.
well, Michael and I belong to them on Sundays.
I thought it was quite motivational. The examples Jeremy gave during the lesson about different people and what things they did. One particular thing was how you don't actually need images, right? Like the one person was creating pseudo images by tracking mouse movements on a screen, user mouse movements.
Yeah, this fraud detection, that was really interesting.
Right. I'm trying to think of some other things along those lines to test out.
I think they put that into production as well. But it was mentioned that they put it into production, the fraud detection.
Yeah, it's working in Splunk.
Yeah. Also, the one guy in the forums posted his work on spectrogram images from audio files to distinguish between different types of sounds. That was very interesting too. So it's basically just creating a 2D image out of a time series from the audio signal.
Mm-hmm. And then what was the what were they trying to distinguish or identify or classify?
So yeah, there was 10 different classes of urban sounds, I think, like I don't know, engine sound and some construction site sound and stuff like that. And so he made this 2D images, spectrogram images out of that, and then he tried to classify which sound that was, 10 different classes, and that worked pretty good up to I think 2% to be state-of-the-art classifier.
From my point of view, I do feel a desire to learn more and read some papers and things like that. I did read the paper about the cats and dogs data set, for example, although their model was 5 years old and is not very good at all. But at least during this course, I will probably try to focus on running the code, getting other projects, doing my own small projects, which I think will help a lot in understanding more what's going on in the code, maybe looking at some of the function documentations, maybe a bit of the source code. And I think there'll be time later to go into some, like read some papers and other things to go into some more detail. So I'm going to try to embrace for the moment the top-down approach and just, like you said on the first slide, I think run the code, and in particular, stepping through the notebook is one thing, but actually having a small problem of your own in which you apply the things in the notebook, I think really brings a different level of understanding.
Yeah.
And the code underneath the library is also pretty beautiful if you look at it from Python perspective. I got to learn about static typing by just looking at the untar data functionality under hood. So it's broken into small functions, everything. So it's a pretty good way of learning Python as well.
That's nice that they include the new features, right? So the 3.6 data set and type hints and stuff. So it's pretty super modern Python. So it's good. I mean, I still can't get over his line styles and how he names variables. That's still freaking me out, but the other stuff is really good.
Personally, to me, it takes an hour or so to just understand a function that they've written, but just because they use proper Pythonic code, and many of it is new to me.
Yeah, it's very time consuming. Even I'm struggling keeping up.
One thing that's helping me is I'm installing Fast.ai on my computer, and I have not been spending a lot of time actually running the notebooks, but now I have been, and I'm finding that that's really helping me learn more about how things are structured and how things work. Ordinarily, I wasn't really doing much, and so taking on that project of trying to install it, has expanded, my interaction with it.
I found what's encouraging was that the cricket versus baseball one, where you only need 30 images to train the top layer. So you don't have to go hunt for thousands of images. It's pretty cool.
Yeah, so I think also this time Jeremy doesn't go that deep in the first lesson. There was no mini lesson on the learning rate, I think. So that the new library, I think by default takes 0.03, I think, as a learning rate. So if you're just using the learn one cycle, you can only specify how many epochs you want to run, and then it takes everything else as default. I'm not sure what else it takes as default. I wonder if also the restarts and number of the multipliers, I'm not sure, possibly, but I didn't check that yet. Like what I was also looking at the data, I think data bunch we're going to have later as a mini presentation. But so my question, I didn't look in the code that deep in the code, is whether that the batches, the mini batches, are they created in that function? I think so, right?
In the data bunch function.
Yeah, all right, okay.
You can specify a batch size.
Yeah, and then it creates those mini batches there, right? Okay, and stores them somewhere. Yeah, yeah.
Yeah, but that kind of stuff would be a really good topic for those mini presentations. So if someone wants to look into the code and let's say, yeah, disassemble the image data bunch function or the learner, the conf learner or whatever, that would be great. So to walk through this structure of the library.
Yeah, agree. We're fantastic.
Yeah, if you walk through the code, I've been a part of the one other group called Data Science India, which has been doing the Fast.ai internals based on the previous version of Fast.ai, and they basically have been using the developer notebooks, and that really gives you an insight into how the learner class is built, how the data bunch is kind of made, and so it's really insightful. And maybe I can try my hand at doing a presentation next week on how that data bunch or learner class is built.
Yeah, that'd be awesome. Yeah, I just forgot that they're all doing all this stuff in notebooks. That's even better to read them.
Absolutely.
Yeah, I think the second part of the course goes more into details about the the underlying parts of the Fast.ai library, if I'm not wrong. Does anyone know if that's true or?
Yes. So I think what he's doing in the notebooks is going to be part of the new part 2 deep learning for coders. That's what I understood. So he want to show how to create those library from scratch.
So I think there has been a lot of speculation also as to what the version 2 of this particular course would be, the part 2 of this particular version 3 course would be. And the grapevine is what people say, as you said, he will go into the specifics of how the library would be, could be constructed going forward. That's why we feel that the second lesson in this particular series itself is on image segmentation, whereas previously it was not so. Usually the version 1 is pretty light on that kind of specifics, and the version 2 or the part 2 is more heavier.
Yeah.
So indeed, the lesson 2 is already on GitHub, and it's different than last time. It's different than the V2. It's interesting. They've changed the course. So last time they had dogs and cats, like only categories. Now they start with 37, one step higher, I would say.
Michael, I think your connection is
quite interesting. Yeah.
Yeah, you're breaking up, Mikhail.
Yeah.
So I guess I'll just jump onto the to my part of it then. So this, I decided to just read some code and just map it out. And so basically what you're looking at here is, physical structure of the files and directories versus the logical namespaces. And this is just, you can all get this by just opening the directory structure and stuff yourself, but I just thought I'd put them side by side. On the left here is the Fast.ai library. What you're looking at, I just did the text art of the directory tree. All the upper cases are directories, but in real life, they're lower cases if you look in your file system. But I just put it as uppercase on the diagram to make clear what's a directory and what's a file. On the right side, it's the PyTorch. DP stands for dist packages. Yeah. So so on the right side, you have 3 packages here: Torch Text, Torch, and Torch Vision. I only just expanded Torch and Torch Vision. The other thing to note about this diagram, the legend of this thing is, all the lower cases are files, and the dot means .py. So for example, the top left here, you have callback dot. That means it's callback.py. There's just too many .pys for me to list. It's just clutter. So I just put a dot there for .py. And the blue is actually, the code I found of interest in there, and how what we see in the notebooks, how that maps to the files. Let's see what's so for Fast.ai, the top blue line is fit one cycle. We've all ran that. That's in the train.py directory. Of course, in the notebook, you can also say question mark, fit one cycle and run it, and it'll tell you the file. But this diagram also gives you sort of like the context, what calls it, like in importing, what imports what modules. So fit one cycle, it's in train.py, and we create a learner. It's actually, this number 2, blue in the middle left here. We use a conv learner class, and that's in the learner.py in the vision directory. So like conv learner is its subclass is the learner class, which is in basic train.py. These are all the blue ones I'm reading, right? And a learner actually, surprisingly, subclass is nothing. But it gets all its properties by attributes. It declares a torch.nn.models, for example. Sorry, model.module. So the learner is actually it's not a subclass of anything. The fit, I don't know if the fit function, I guess it's kind of superseded by fit one cycle if you're only doing one cycle. But if you're doing like multiple cycles, this is like if you've been with us for the last 6 weeks, we've done multiple cycles, and that's where the fit function lies.
Sebastian, do you think that's the case? I think the fit one cycle refers to the one cycle policy. I think I didn't really dig into that, but seems to me that they've implemented this paper on the one cycle policy. Not exactly sure what that means, but kind of improves the accuracy and maybe speed.
Well, if you want to do fit multiple cycles, like a learning rate differentials, you can't use fit one cycle anymore, right?
I'm not sure. Maybe you could. I would need to.
We can pass it a slice that works.
Parse a slice. Okay.
Yeah.
So we don't need fit anymore?
Fit is like the older paper from Leslie Smith, and fit one cycle. Probably Jeremy would be telling more about it in the second lecture.
Okay.
That's a new paper which came out in April this year. One cycle policy.
Yeah, I think that's confusing because it seems like it's referring to just one cycle, but I think it's referring to the one cycle policy. I'm not quite sure how is that related to how many cycles per epoch you want to run. It's something that we can also do as a mini presentation. Yeah, I think so. Yeah.
Okay. All right. The other thing of note that was interesting to me in the code is saving a model and loading it. So that excuse me, that is on this upper right a little bit in the serialization.py file, and I guess it saves it as a PTH file, PyTorch file format, which is like not really the ONNX file format, or sometimes it might. I think it actually. No, you download the weights as PTH, and then I think somewhere along the line, I think it might save it as an HD5 file format, which is, I think, a hierarchical data format 5 or something from some supercomputing center format. So that's how it saves and loads and downloads your weights. So that's basically my walkthrough of the directory structure. The other thing I kind of did that was that I had to do for myself is print out the weights. So so I mean, if you just run learn, it'll print out your model, right? With in this case, it's a ResNet 34, and it starts here and it goes through many more layers. But if you want to print out the weights, just for your own sanity checking, self-gratification, here it is. This is how you do it. This is just the first layer. It's a kernel size of 7 by 7. So you see like 49 weights here. And you notice the weights are all, fairly small, 0.0 something, right? 0.01, 0.05. So, so if you keep on doing many layers of these weights, your activation is going to become like super small. So I think that's where the ResNet helps. It has this identity function that well, it also copies the input, I think, from the previous layer. So
did you also have a look at the activation map that's generated by this by those filters?
I did not look at the activations yet. Do you know how?
Yeah, well, I mean, I don't know how to get it out of the library, but you can do the operation with the filter on the input image, I guess.
Okay. Yeah, I think.
But
yeah, it must. There's. I think there's probably some data structure path that you have to, I climb through to do it. I don't know how to do it by just doing the convolution and.
I have one question. While running fitting the model, I ran the same data and got different numbers, which probably would be because of the images are picked at random. So is there a way to reproduce exactly the same result? Because if you run the code multiple times, you end up getting different error rate.
Well, I think I usually get pretty close to his results. Sometimes if I run the learn function multiple times, of course, then, your weights are going to start drifting from what he has, and your activations are going to start drifting. Or if you run different fits, like fit one cycle, if you run it multiple times or something like that, maybe you can start to get different results.
Were you asking like how to reproduce previous runs, or?
Yeah, how to reproduce previous runs.
I just was to this PyData Germany conference, and they said basically you can specify your random seeds in Torch and in NumPy and everywhere basically. So there was a dedicated talk about how to replicate.
Yeah, that's even my understanding, but which function in Fast.ai library would take that random seed?
I think you probably need to drill down into Torch for that.
Okay.
But I don't know. I mean, I haven't really looked into that.
And in the code, he's using the random seed, and he sets a 2. This is just before he ran the image data bunch. So maybe there's more of those needed, but there is already something to that extent.
Does anyone know where in this retraining setting there are random numbers needed? Because I mean, the weights are from the ImageNet training, and they're not initialized. So
I think it splits data into training and validation sets, and that could be random, I guess.
That's also how they form mini batches. That's where you use random generator as well.
Okay, yeah, makes sense.
Okay, I think I'm going to just stop here, and I'm going to stop sharing and send it. Kai, you want to share your desktop?
Yeah, yeah.
Let's see, I don't know how to do this. Okay, we're looking at bicycles.
Yeah.
All right.
Okay, so yeah, this one. Yeah, so I created a image classifier that takes keywords. So you just specify some keywords or search words, and then it downloads images from Google search, and yeah, trains a classifier on that. So I'll just go through the notebook. It's nothing fancy here. The imports, you know that. So this is the package I use. It's called Google Images Download. You can find it on GitHub. And yeah, you can just pip install it, and then you can use that. And the way it works is that you import it, and then you instantiate this Google Images Download class. And yeah, you specify the arguments. So you specify the keywords you want to search for, and the limit, the number of pictures you want to search for, and some other stuff. So where to save those images, and also the Chrome driver. I'll talk about that in a minute. And yeah, then in the class you have this download method, and you parse the arguments, and then it's starting to download. So if anyone has an idea which classifier we should create, you can maybe just pick two things that you can specify.
How about hammer and wrench?
Hammer and wrench, okay. Hammer and wrench. Okay. Yes, so let's see. I think I'm gonna restart the kernel, so we start from scratch. Import. That, and then hammer and wrench. So I'm just creating a folder that's called hammer wrench for the data, and then I'll start the download. Yeah, and now it's downloading the images. So with this method, you can download, I think, a few hundred pictures, because that's what I wanted to show you with the bicycles. The thing is, you can retrieve the URLs from these pictures, but at some point you reach this this button, show more results. And to load more pictures, you need to, that's what I understood, you need to emulate a browser to do that. And if you want to do that, you can install the Chrome driver. I have installed, how to install it is down here in this notebook. So you have to run this on your, so this is for Linux. I don't know if it's possible to run that on Windows. I guess not, but on Linux it works pretty good. So when you want to load more pictures than that, you need to do that. I did not try to load more than, I think, 200 pictures. Yeah. And it's loading the images and putting it in separate folders. So it creates one folder for hammer now and one for wrench, and it's putting in the images into these folders. And I specified that it's should put this in the train folder. Okay, so when you skim through those messages, it downloaded 100 pictures for each class. And yeah, so one thing I experienced was that there are some pictures that are corrupted and that are crashing the learner in the later stage. So I made this little snippet to clean those. Let's see how many corrupted pictures are in this. Yeah, there are a few. And I'll remove them. Actually, this method here, in a way more nice and multi-processing way, is now implemented by Jeremy since Thursday, I think. I just saw it in the repository. So there is a verify images method now in the library too. I think he saw I had a discussion with some other guy in the forum, and he decided to quickly implement this. Yeah, and then at the moment, so let's see, We have hammer wrench. There is only the train folder, and inside the train folder, we have wrench and hammer, and there are the pictures in those folders. And we have to create a valid folder, or I mean, I think there is a method that where you can just specify a percentage of the pictures that should go to the validation set by. But I used this little for loop to create a validation set, and I'm choosing 30 of the 100 pictures for validation here. And then I am initializing the image data bunch and normalize it. Yeah, and there are some pictures always that are downloaded that have an alpha channel for transparency. And he's I think it's from, okay, it's from the pill package. It says that it should be converted to RGBA, but it worked like that. So I did not write a function to correct that. Yeah, and now the learner, and we fit 4 cycles. By the way, this is running on my workstation at my office. And Sebastian, here you can see the terminal. So when you are on Paperspace or wherever, you can click here and click on terminal, and then you have a terminal. So,
and next to that is also upload stuff.
Yeah.
Yeah.
So I'm here. This is inside my Docker container.
Some platforms might charge you for uploading huge chunks of data, so you might want to look out for that.
Yeah, yeah. Okay, train. So this seems to be pretty good. Let's save that and then do the classification interpretation. That's, by the way, a really great class and methods here. So now we can plot the top losses. And let's see if let's have a look at the confusion matrix. So there are really just a few images that are misclassified. And yeah, I mean, this is this is a picture that does not belong there, but I mean, it's there are not checked those images, but yeah, it works pretty well. So I mean, hammer and wrench is something that where you find thousands of images on Google. If you have something more special, then this is certainly not going to work. But yeah, I mean, you can go on and unfreeze and do the learning rate finder, and oh yeah, there are some RGBA and go on. So I'll not do that now, but it pretty much works the same like the other data sets that you use, or yeah. So if you do that extensively, you can maybe leverage or copy the model that Google uses to classify their images or annotate their images.
That's really great, Guy.
Yeah, I mean, it's more fun. It's not really serious. But if you want to really quickly create a classifier, then maybe that's for first shot, that's feasible.
Guys, just a heads up. I mean, I don't know if anyone wants to put in like more data. So I just updated my script, and that's pulling now like from Baidu, Bing, and Google. So you can easily get like 1,000 images per class. It takes a while to pull this stuff down. I posted that in the Slack.
So you have a script for scraping images from.
Yeah, and you don't need Chrome driver, and it's actually pretty good because it also eliminates duplicates. So it computes a hash on the actual
Awesome.
file, and it resizes to 299 or something.
Yeah,
and
that sounds much more sophisticated.
Yeah, I kind of started like with the last version, and then it just died, and then now I revamped it. I also have a small GUI to visually inspect and mark files that don't belong in a class, so you can quickly delete them. So
Awesome.
if you guys are interested, I'll post the link again. And
did you post that on Slack?
Say again?
Did you post that on Slack?
Yeah, it must be buried somewhere, but I can quickly repost.
Awesome.
So I just did that, and basically, you can provide a CSV file with search terms, and then it'll basically build your categories based on these searches. So in my example, I have like 25 different guitars, and it'll produce 25 different categories. Problem is that a lot of them are just dodgy, and then you use the second script, the GUI, to delete the wrong ones, basically.
And how did you get around the Chrome driver thing?
I use iCrawler.
Okay.
It's pip install iCrawler, and I don't think it needs the Chrome driver.
Awesome.
I mean, I could quickly share the GitHub thingy. Do you? How would I take the screen? Is it possible?
It's the bottom, the share button at the bottom.
Ah, okay, yeah. Sorry.
We have another mini presentation coming up.
Yeah, we do with Sanyam.
Okay. So we're not cutting out at 1 hour, but doing a little bit longer, or?
I'll try to get it over soon.
Okay.
Okay. Yeah. Well, I'll just post the link, and you do your mini presentation.
Okay.
Yeah, maybe you can do a mini presentation next time.
Oh yeah, yeah, sure. I also,
yeah.
I mean, I was short on time, but I'm gonna write a small blog post, and I can do a mini presentation next time. Sure.
Awesome.
Fantastic.
Hey, Sanya, you want to share your screen?
Yeah.
I think we have that in the slides, right, as well.
So can you see my screen?
Yes.
Then your connection is pretty bad. So maybe when you switch off the video connection, you have more capacity for your voice. That be okay? I hope that works. It works like that.
It should. Is it better now?
Yeah, pretty good. Yeah.
It's good.
All right. So I'm just trying out to build another not hot dog app. And right now what I have to present isn't much interesting, but the idea behind is that I want to recreate the same app, but I want to run it on the mobile, and I want to create it in PyTorch. The original creator, they've used Keras and TensorFlow, but I want to use PyTorch for it. So I simply, instead of scraping the internet, I just use this dataset on Kaggle, the link that I've provided. And I tried unfreezing, but still the results were getting worse. So this is the final code that made it. I was about around to 88% accuracy. And that was fine for me because I just wanted to check if what should be a good accuracy on this, and if it's possible to differentiate normal food from hot dogs conveniently. And again, the reason behind this is next I want to create this on another architecture, probably SqueezeNet or MobileNet. Those are the ones that are suggested for running on a mobile. And another friend from the Fast.ai Asia community, he's trying to export the model as a Cafe2, I think, object. And the next step would be to import the model into, or probably Onyx model into a mobile app. And I'll share the progress as we go forward, but right now this is what I had. And I mean, for starter, it was a good project because, as you can see, the misclassified objects are just wrong images in the dataset. For example, there are French fries on the hot dog in the first image, and the second image should not be there, I guess.
Sayam, would you be having any resources around building an application around your model? So that would be great if you can share it on Slack or something.
Book has the boilerplate code. I'll share that. It's pretty simple once you're able to export the model to Onyx. Even though PyTorch 1.0 supposedly is a PyTorch to PyTorch integration, but the current way around it is you need to export it to Onyx. Okay. And they provide boilerplate code for that if you want to import it into your application. I'll share that.
Okay.
Yeah, so that was pretty much about it. And I think furthermore, I'll share if I have any progress with the app. But that's about it.
Very good. Very nice. We'll be interested to hear progress on that for sure.
Yeah, absolutely.
So maybe you can continue to the next slide just to finish the thing. So for the next steps, of course, the next lesson is Tuesday. Can watch it live or afterwards, whatever works for you. And then try to do homework, wherever Jeremy suggests. And then I think, as we mentioned, it's good to have a project on the side to kind of implement the learnings or some like Kaggle competitions. Seems this time Jeremy is not using that much of Kaggle data sets, Kaggle competitions, but I think still good learning to do Kaggle. So that's for next week. And the last slide is some resources. There are on the forums. Forums is a good resource. On the forums, there are 2 threads that you possibly want to watch. There are 2 official threads about lesson 1, and I guess that's going to be lesson 2 and so on. And the official resources and course updates. So whenever there is any update, Jeremy or whoever posts that, and if you watch that thread, you go into notification that something was added or changed there. So it's a good way to be up to date with the course. There is a thread to share your work, so it's also a good way to show it. Jeremy's commenting on many times there, so it's a good way to share your work. Yeah, I think that's it.
A quick question: does anyone know? Was there any info on sharing stuff online, like writing blog posts? Should we go through some vetting in the forum first, or is it okay if you write your own and don't link the official ones? Or
I think it would be better to share on the forum under the share your work thread.
Just to be sure.
If you feel there is something that Jeremy would not want to be shared publicly, it would be better to get it approved.
Yeah.
Yeah, I think the point that was made is that as long as your blog doesn't point to a link, a public link that is privately shared between the students, that's okay.
Okay.
Until they officially release these links.
And I guess Jeremy also doesn't want you to mention the GitHub link even to the latest course, so that's also something that we need to be aware of.
You have other docs as well, I suppose.
Okay.
Okay, excellent. So thank you for joining today, and hope to see you next week.
Yeah, thanks a lot. And
Thank
if you want to
you.
do a presentation, reach out on Slack.
Cool. That was fun.
Thanks. Bye.
Bye. Bye.
Bye-bye.
Bye, everyone. Take care. Bye. Good night.